So today in Discrete Mathematics, I am taking lecture on Propositional Logic. I am Amit Kumar, Assistant Professor, IT Department. Today I am going to deliver a lecture on Propositional Logic. So in this lecture, we are going to see about what is Propositional Logic, what are the statement, how to create a conclusion, what are the logics, and what are the formulas we are going to put in that one to create a logic. So in so what in this slide we are going to state that what is the propositional logic. A proposition, what is proposition today? A proposition, or we can say that it is a statement. In this we are creating a logic, so we have this statement and we have the conclusion also. So for the statement there is a given statement over there, and there is conclusion also given there, so we have to find the conclusion using the statement. In these statements are also called the hypothesis. We can say also a proposition, or we can say the statement, but in the easy language we are saying the statement. So a statement or a logical sentence is a declarative sentence which is either true or false. This is the proper definition of propositional, that it is a logical statement or it is a declarative statement which is either true or false. It means the statement statement is given true or the statement is given false. So from these statements we are going to create our conclusion, and we have to find the conclusion using the logics. So there are some basic examples for the proposition. So we can say that the sun rises in the east. This is a true statement, so we can say that this is the true statement. This we can say that all the women are independent. We can say that, but this is a question mark. Is this is a T? This is a question mark question mark questions. So we can say that there are too many statements, there are so many statements over there. So how we can say that it is a true statement or false statement? There are some following examples. So the following statements are: Jawaharlal Nehru is the first Prime Minister of India. It is a true statement. Okay. It rained yesterday. It can be true or it can be false, but now we can say that it is a true statement. For this reason we can say that this is a true statement. If x is an integer, then x square is a positive integer. It is a true statement. So we can say that. Now I am putting a question mark question, that is apple is fruit, or is apple is vegetable? This is a question mark statement. So we can't decide this one is a true or this one is a false statement. So there is a following statement which are not propositional. Please report at 11 a.m. sharp. This is not a propositional because these statements are not clear. So what is your name? This is I am saying that I am saying about the declarative sentence. So this is not a true propositional statements. X square is equal to 13. This is not a true statement. So there is a propositional variables. So how to write the propositional variables? We can use the first letter which is in the lower case, which stand on the propositions. They can say as they are the propositional variables. Like in the given statement, the lowercase letters starting from P onwards are used to represent proposition. I am not saying that we can start from P. You can start from A also, but in the easy language we are using P and Q. So this is the P statements. So we are writing P statements onwards to represent our propositions. So here P statement is India is in Asia. It is a true statement, and this P is a proposition variable. Okay. So now this is a true statement and P is a proposition variable. For the further numerical question or solving for numerical, we can use only these variables. Okay. Now Q is 2 plus 2 is equals to 4. So Q is also propositional variables. We can put any other variable. B, apple is a fruit. Okay, we can say as carrot is a vegetable or fruit. We can put like this. We can say that these are the propositional variables. Okay, from the previous slides we know about what is the proposition and what are the propositional variables. Now in the next slide there are compound statement. Compound statements means statements or propositional variables can be combined by means of logical connective operators to form a single statement called compound statement. Here there are connectives. Okay, so from the logical connectives we can make a single statement which is known as a compound statement. So there are connectives, we are using the connectives to create a statement. So this symbol, if you are not clearly visible, I am making this is not symbol, this is not symbol. Okay, we can say this is not, and its name in this proposition is negation. We can say this is a negation. Okay, now this is and, this is or, this is implies or if then, this is if and only if. Okay, and, or, implies or if then, if and only if. And we can say and operation as a conjunction, disjunction, or operation, implication, or conditional. We can say this is a conditional statement. This is a conditional statement, and this is called as a biconditional statement. Okay, now these two signs used in our first module for the lattice, and they named different, but here we are using this sign as a and or for the connectives to create our statement meaningful. Okay, so that we can find our better conclusion. So there are the basic logical operations. First is negations. As I told in the previous slide, this is connector, so we can know about what are the uses of these connectives, and further then we can go that one. So first is the negation. It means the opposite of the given original statement. We can say that if P is statement, then if P is a statement, then the negation of P is denoted by not of P. This one. If P is the statement, then the notation of negation not of P. This is true statement, then it would be false. This is false, then this would be true statement. This is the use of negation. This is the first logical operations on the proposition negation. Now next is conjunction. We can say that this is an and operation. It means anding of two statements. If P and Q are two statements, then P and Q is a compound statements denoted by P or Q. P and Q. And reference as a conjunction of P and Q. We can say that this is the conjunction of P and Q. The conjunction of P and Q is true when both P and Q is true. Otherwise it is false. We can say that as we have learned in the logic in the Boolean algebra, what is the truth table of AND operation? If true, then true. If anyone would be false, then it would be false. That statement I have wrote there. The conjunction of P and Q is true only when both P and Q are true. Okay, only when both P and Q are true. Otherwise, it is false. So this is P, this is Q, and this is P and Q. So true, false, true, false, and false. You know that one very well. So I am skipping this one, like, and disjunction. Disjunction means ORing of two statement. If P and Q are the two statements, then P and Q is a compound statement denoted by this sign. Okay, and it is referred as the disjunction of P and Q. At least one statement is true, then the conjunction of disjunction of P and Q is true. Okay, like this one, P, Q, P or Q. It means true, 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 false, true, false, true, true, false, false. Here would be false. Okay, the two statements are false. So this is the disjunction. Now the implication, that we can say that this is conditional signature. Okay, sign. Sorry, signature. Sorry, sign. And implication P and P conditional Q is the proposition. If P then Q, it is false. If P is true and Q is false, the rest cases are true. Here we are saying that from the truth table we are going through this one condition. P Q, P conditional Q. If true, true, then true. If true and the second statement is false, then false. This statement is saying that if it is false and P is true, then Q is false. Okay, then here the first statement is false and true, then true. Here false, false. Okay, this, only this condition. First statement is true and the second statement is false, then it will be the false. Otherwise, all the statements are true. This is the conditional statement. Now next, biconditional statement, where P and Q are the same, both are false or both are true. This is the biconditional statement. P, Q, P, bidirectional, Q. True, true, then true. True, false, then false. Obviously, false, true, false, 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 true. Here there's two statements. If any one would be the false, then the output of the biconditional statement is false. Okay. Now here is an example of that one. Let P, this is the variable. Okay, propositional variable. P, Ravi is rich, and this Q, Ram is happy. There are the two statements. P and Q here given the statement. And the question is asking, write the following statement in the symbolic form. Ram is poor but not happy. Ram is poor and not happy. It means Ram is poor. Ram is not happy. It means not of Q. Okay. And poor. Okay. Not of P and Q, because Ram is not happy. Ram is poor but happy. Okay, Ram is poor but happy. Ram is poor, but P's condition is saying that it is rich. So not of P means Ram is not happy and not rich, and Q means it is happy. Okay. Second, Ram is neither rich nor happy. Neither rich Ram and nor happy. Okay. These are the two statements. We are putting the negation sign over there. They are the derived connectors of also to use. Okay, NAND. It means negation after ANDing. Means we use the AND operation with negation. Okay, of the two statements. Assume P and Q be the two propositions. NANDing of P and Q to be the proposition which is false when both P and Q are true, otherwise true. Here we are making P, Q, P negation Q. Okay, we are saying this one. Okay, true, true, then false. Okay, true, false, then true. Only the true statements are the false. We are putting the NAND operation. NAND means negation of AND. Okay, so the opposite of AND, we are putting false, true, true, false, false, true. This is the truth table of NAND. Now NOR. NOR, we can say that the negation after the ORing of two statements. Assume P and Q are the two propositions. ORing of P and Q to be the proposition in which two are true when both P and Q are false. when both P and Q are false, then it would be the true. Otherwise, all the statements are the false. It is denoted by P, Q, nor. This is Q, this is P. So true, true, false, true, false, 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 true, false, 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 true. Here we are saying that when both the P and Q are false, okay, the proposition which is true when both the P and Q are false. Otherwise, all the conclusion will give the false. Here you can understand that this P is one statement, this Q is one statement, and this we can say that this is our conclusion. Okay. XOR P and Q to be two propositions. XORing of P and Q is true if P is true or Q is true, but not both or vice versa. We are denoting this sign. Okay. So P, true, true, false, true, true, false, true, false, true, false, true, true, false, false, false. Okay, this is the truth table. We are saying that P and Q is true if P is true or Q is true. P is true, Q is true, then it will be the false statement. Okay, now conditional or biconditional statements. Conditional statements, when let P and Q be the two statements, then if P then Q is a compound statement denoted by this. This is, we can say that, conditional statement, and it is referred as the conditional statement or amplification. The amplification P conditional Q is false when P is true and Q is false. Otherwise, it is always true. In this simplification, P is called the hypothesis and Q is called the conclusion. Okay. Now here we are saying this one. P is hypothesis and Q is the conclusion. P, Q, here conditional statement. P, then Q. Okay. True, 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 false, 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 true, true, false, false, true. So, for example, for a conditional statement, if A and B is, if A is equals to B and B is equal to C, then A is equal to C. If I get money, then I will purchase a computer. These are the examples of the conditional statement. It means if A is equals to B and B is equals to C, then A is equals to C. We can say this is the conditional statement. If I get money, then I will purchase a computer. If I have the money, then I can purchase a computer. So from these statements, we are seeing that these are the uses of connectors, what are the statements, what are the hypotheses, and these are the basic logic operations we are seeing over that. Okay, so we have done our, I have done our slides previously. We have done the negation, we have done the conjunction, we have done the disjunction, we have done the amplification, and we have done the biconditional statement. There are truth tables, so we have to create this one. Okay, now this is the conditional statement or biconditional statement. We have to understand about the conditional and biconditional statement over here, because this is the important topic in the discrete for the theory of inference, that what are the conditions we have given if P statement is true or a Q statement is true. Okay, then it would be the true. If P statement is true and the next statement is false, then it would be the false statement. And there are too many rules in the theory of inference. We have to use it. There is so many formulas over there, so we have to use it, that also. Okay, conditional statement and biconditional statement. What is the difference between conditional statement and biconditional statement? Conditional statement says that if any one is true, we can go to the next statement. If in this the biconditional statement, both statements should be the same, then it will be the true. Otherwise, it will be the false statement. So we are saying that this is the conditional and biconditional statement. There are the variations in the conditional statement: contrapositive, inverse, and converse and inverse. These three are the variations in the conditional statement. Contrapositive, the proposition not of Q, conditional statement, when not of Q goes to the not of P, we can say that this one. Okay, here I am going this one, implies or if then, or if and only if, implies or if then. Okay, we are going to the implies or if then statement. So this is the contrapositive. If not of Q implies and if then not of P, then it is called contrapositive of P if then Q. Okay, and converse, the proposition Q to P is called the converse of P and Q, and the inverse, when not of P goes to the not of Q, is called the inverse of not of P. We are saying that this is the contrapositive. Not of Q goes to not of P, then it is the contrapositive P to Q. With the proposition Q to P is called the converse. Obviously, it is the converse of P to Q, Q to P, and this is the inverse, which call that not of P goes to not of Q, then it will be the inverse of P to Q. These three are the variation in the conditional statement. Now, from for an example, we can say that what is the contrapositive. So that there is the example. So that P to Q and its contrapositive not of Q to not of P are logically equivalent. We have to show that P to Q and not of Q to not of P are logically equivalent. So we are taking P and Q, true, 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 false, false, true, false, false. Okay, we took this P and Q statement. Not of P, you can say that false, false, true, true. Not of Q, false, true, false, true. Okay, so P to Q, this is a conditional statement. I have told you that keep when the one statement is false, first statement false, and next statement, then it would be the false. Otherwise, all the statement would be true. Okay, so this is, and this not of Q, not of Q, and not of P. Okay, this is P and Q, P to Q, P and Q. We have took this one. Okay, now for this we are matching that one. We have to, one statement is false, then we are making this statement is false. It means the second statement would be going to be the false. So we are making this one not of P, not of the false, false statement. So true, false, true, false, true, false, true, and true, true, false, true. So these two are logically matching. So as we are right that the values in the both cases are same, hence this both propositionals are equivalent. Now the next example we are showing that the proposition we have given Q to P and not of P to not of Q is not equivalent to P to Q. It means we have to show that P to Q, Q to P, not of P to not of Q. Here showing that show that proposition Q to P and not of Q is not, means these both are not equivalent to this one. Okay, these both are matching. Okay, but this would be not match. So we are writing P Q not of P not of Q because this would be the uses. You know that how to write. So not of P not of Q. So P to Q, one statement is false, that is false, otherwise all statements are true. Q to P, okay, true, true, this would be the false, the next second statement, and this would be the true. Not of Q to not of P, not of Q, not of P to not of Q, not of P to not of Q, means this statement would be the false statement, otherwise all the statements are true. As I have told you that only the second statement is the false, then it would be the, means these two propositions are matching, but these are not matching. So we have to show that the proposition Q to P and not of P not equivalent to P to Q. Okay. Now, biconditional statements, as I have told, as I have shown here, the conditional statement, if P and Q are two statements, if and only if Q is a compound statement denoted by P to Q, biconditional statement P to Q, and referred as a biconditional statement or an equivalence, the equivalence of P to Q is true only when both P and Q are true, or when both P and Q are false. Means when both P and Q are true or both P and Q are false. For example, two lines are parallel if and only if they have the same slope, same slope. Okay, this is the example of the biconditional statement. You will pass the exam if and only if you will work hard. Okay, now here is the proof that. So this is the proof of P to Q and equivalence. So we are making the tables of that one and we are matching the equivalence also. The principle of duality is saying that the two formulas A to B, we have changed the sign, replacing and to or to if. It is the principality. Okay. So this is the law of the algebra of propositions. We are showing this is the equivalent or not from the two table. Okay. These are the tautologies. From this to tautology, tautology means all the statements are true. If all the conclusion are going to be true, it can be say as the tautology. Contradiction means if all the statement is going to be false, this is called contradiction. And thank you.